So in this video, we're going to be discussing how RAG works, how retrieval augmented generation works. Now, if you are still new to RAG, there is a cheat sheet in the description, so you can check the description of this video. There is a cheat sheet where you can see everything I've explained. It's free. It's a free cheat sheet, so you can just download it and get up to speed with what RAG is all about. But this video, we are discussing how RAG works and how we're going to be implementing it in the full series. So RAG has two stages. And the first is the ingestion stage. Now, the ingestion stage covers everything that has to do with taking all your private data, chunking it, embedding it, and saving it into a vector store. That's what everything in the ingestion stage is all about. So what happens here is that you take, let's say you have let's just put a square there. So you have all your information, you have all your files. Let's say we have PDF files, we have markdown files, different types of files, even web pages. So we have all these files, and the first thing we're going to do is to load them. We're going to take all these files, get all three of them, and we're going to load them into an intermediary store. So we load them into more like a data lake. So we just dump them somewhere as documents. So this is the first stage. Like I said, this is the load stage. This is what is called the load stage or the load step. So this is the load step. You load all your documents, PDF, markdown, images, media, any type of media, videos, audio stuff. You just load everything into this database. Now, once that is done, you will then need to split all these documents. You need to split all these documents because your LLM cannot, or rather your vector store is not going to take them as a whole. So if you have like a book, let's say you have a book of MySQL, we're not just going to take the whole book and embed it and put it in the vector database. We need to split it. So I'm going to split it up. Let me make this the background. So we're going to split this up into different chunks. Let us represent the chunks as this. So we're going to split it up into different chunks. That are going to be of sizes that we can process and we can embed. You don't want to embed an entire book or an entire video. So we slice and dice it. And at this stage, which is called the splitting stage or the chunking stage, so you can call it anyone you like, so split or chunk, because you're actually creating small chunks of your documents. So this stage, you slice and dice your document and you can define the size of each chunk. Another thing that you can do is that you can actually specify an overlap. For example, if you're breaking a whole document, let's say a web page, you can specify an overlap, because if one chunk stops at a point, it might be too abrupt and it might lose context. If another chunk starts from somewhere, it might not have context enough to really understand what is going on in that chunk. So you can specify an overlap and say, okay, A overlaps into B with, let's say, 500 characters, and B also overlaps into A with 500 characters, so that you can just maintain some sort of context. This is also where you want to do some optimizations, using some advanced strategies to make sure that context is not lost. But anyway, you have to chunk them. And the next stage is the stage where, just get this and duplicate it. The next stage is where we embed them. So we embed this chunks. Let me just say embed. So we embed these chunks, and we do that using an embeddings model. So you get an embeddings model. You can use one from Hugging Face, or you can use OpenAI's embedding model or Gemini's embedding model. So you take that embedding model and use it to embed these chunks and produce vectors. So here what we have is vectors. So I'm just going to just represent that with say just some values here. So we make them into vectors, because this is the representation that our models understand. So we convert them, we embed them, which is the process of using an embeddings model to convert our chunks into vectors. So once we get them into vectors, we can then store them. We can then store them in a vector database. So it's our store. We'll store them in a vector database. Yeah. So these are the steps. These are the steps for the ingestion stage. The ingestion stage, like I said, the ingestion stage simply is all about taking all our raw documents and converting them into embeddings and storing them in a vector database. Let me put vector database here because that is very, very important. So you can use a vector database or a vector store. You can use Pinecone, you can use Chroma, anyone that you are most familiar with. You can even, if you are a Postgres fanboy, you can use pgvector, the pgvector extension, and just use Postgres. So we'll store them in a vector store, and this is a store that we're going to be querying in order to get context for any prompt that comes from the user, which is the next stage we're going to be talking about. The next stage is the generation stage. The generation stage. So ingest, from ingest to generation. So the next phase is the generation phase. And generation phase is what you're going to be doing a lot. This ingestion phase is more like the write phase. It's more like the write phase for this whole RAG process. The generation phase is your read phase, is the read. And you're going to be doing it a lot because every single time a user asks a question, you want to query your vector store to see if you have documents that can provide context for that particular query, and then feed it into your prompt so that your LLM can have more context to work with. That's how you can get all your company information, private information, real-time data, and everything into your LLM's context. So this is generation phase. And the generation phase, what simply happens is that the user sends a query. So the user sends a query. So it's going to be user query. User query. So the user sends a query. And then we take our vector store. By the way, let me give it color. Let's say green, so that we can know that that's the guy. So we take the query, we go into our vector store. Our vector store provides something called a retriever. We're going to be saying it when we code out this entire process. So our vector store provides something called a retriever. And when we send our user query, the retriever is going to go into our vector store and it's going to search for documents that match the user's query so that I can return them as context. And we can tell it how many documents we want it to return. We can say we want to return 5, we want to return 7, or we want to return 100 most relevant documents. There's actually some heuristics to understand, or rather to be able to know the maximum number of documents you should retrieve. So we get those documents, and these documents can be searched by match or semantically. It's always advised that you go semantically because that is actually the beauty of vector stores. Vectors help to define relationships between words, phrases, documents, what have you, information in general. So our retriever gets us the chunks. It gets us the chunks that relate to the user's query. So we can then take those chunks and mix it in with our prompt. So at the end of the day, you're going to have, let me get this box. At the end of the day, you're going to have a prompt that is made up of some of the embeddings retrieved, from your vector store, and the user prompt. Let's say the user asks a question such as, what is tax? What is tax? So the final prompt is going to be the user's query, which is what is tax, and the embeddings that have come from your vector store. The embeddings that have come from your vector store. These are then mixed together and sent to the LLM. And when these are sent to the LLM now has context. This is the context, this is the query. It has context that it can use to answer you, or rather to give answers that are grounded in your private information. So it doesn't just use its knowledge base, it takes information directly from you. Let's say, for example, you're developing some internal tool to onboard new workers, and you want them to be able to ask questions about your company policies, about your bylaws, about your product and stuff like that. If you just feed that to an LLM that has no context about what your company doesn't have your company's private information, it will just hallucinate a lot. It will hallucinate a bunch of crap. But because you're now feeding it context from your own private documents, whenever they ask their questions about your bylaws, about your product, the LLM is going to be able to specifically answer them based on your knowledge base. One of the cool features I've seen these days is the fact that a lot of people are putting chatbots on their documentation. The LangChain documentation also has it. So people are putting chatbots on their documentation, and you can just simply query the documentation instead of searching around trying to look for answers. You can query the documentation, and it can feed off that particular. Let me get the lasso tool. It can feed off the documentation to answer your questions. You can feed off documentation to give you answers to your questions. So, and I've gotten to use that a lot. Even on the LangChain documentation, I've used that a lot. I also saw one on a site called render.com, which was pretty cool. So yeah, these are one of the use cases where you can have an LLM grounded in your information and to provide value to your users using RAG. Straightforward and simple. So now that we understand the steps, we can then start building out our RAG pipeline.